Welcome back to the second part of our lesson on factoring. In this lesson, we're going to focus exclusively on factoring the sum and difference of perfect cubes. And in our last lesson, we learned how to factor perfect squares. And we were not able to factor the sum of squares, but we were able to factor the difference of squares. Well, in this lesson, we're going to be able to factor both the sum of cubes and the difference of two perfect cubes. And I have on the right-hand side here, this is the sum of two perfect cubes and the difference of two perfect cubes. And both of these will factor into a binomial multiplied by a trinomial. And the formula for doing that is basically taking the cubed root of each perfect cube. So you're going to have an a plus b factor for your binomial. And then your trinomial will be the square of the first term, the product of the two, and the square of the last one. And it follows the same format for the difference of two perfect cubes. The only change you'll notice is the sign. Okay, this sign is different. And I have a little mnemonic device for you to be able to remember that as well. We'll get to that very soon. So let's take a look at an example. We want to factor this perfect cube. And first of all, we need to make sure that both of these are perfect cubes so that we know that it will factor. Well, the first term, we could write that as just x to the third power. This term, we need to find the cubed root of that thing. So on your calculator, you could type in 512 and use your caret key and raise it to the 1/3 power, and you would find that that is the perfect cube of 8. So 8 to the third power gives us 512. So now what we're going to do is we're going to square the first term, multiply them together, and square the last term. And that is how it factors. Now here's the mnemonic device for remembering the signs. And the first sign in your factor is the same as whatever sign you had to begin with. So if it's a sum of cubes, then this will be plus. If it's a difference of cubes, this will be minus. And SOAP is the word that we're going to use. So it's same sign, then opposite sign, and then the last one is always positive no matter how you're factoring. So same, opposite, always positive spells SOAP. Let's take a look at another example. 8x cubed minus 125. We need to find a way to write 8x cubed as a perfect cube, and that turns out to be a 2x to the third power. 125, the cubed root is 5. So now let's just go ahead and apply the formula that we had above, okay, where we're going to square the first term, multiply, and then square the last term. It's very similar to what we talked about with perfect square binomials, where we multiplied and doubled, but we don't double the middle term. So this one is 2x minus 5 is our first term. It's whatever your a and your b terms are, same sign. Opposite sign for the next one, so we're going to square 2x, gives us 4x squared. Square 25, or excuse me, square 5 gives us 25 for our last term, and then just multiplying the 2x and the 5 together gives us 10x. And the signs are the same, opposite, always positive. Two more examples, and then I'll give you a couple to try on your own. Cubed root of 216, not sure if you recognize that, but that is a 6. And then a to the third, the cubed root of that is just a, so it's 6a, the quantity to the third power. And then the second one is just a b. Now we're going to square the first term, well actually our first binomial is just going to be 6a plus b. But then the second term will be the square of the first term. 6a squared gives us 36a squared. Then we're going to multiply together, we get 6ab, and the last term is b squared. Last one, 1000x cubed, that's a 10. And the x cubed gives us an x, and then 1, the cubed root of 1 is just 1. First term is going to be 100x squared, and middle term will be 10x, and last term will be 1. And then whatever our factors were to begin with is our binomial. So that's how it factors. And if you were to expand this thing the way that we learned in the previous, I think 2 sections ago, you would get right back to the thing you started with. So you can always check your answers. Here are the last two for you to try on your own, and we can talk about those when you come to class. See you next time.